For our project, we focused on the survival package in R. This package's main purpose is to analyze survival analysis datasets. Survival analysis data is time to event data. This means that the response variable is the amount of time until the subject experiences the desired event. Since not all subjects experience the event during the time frame of the experiment, some event times are censored, which means that a plus sign is placed at the end of the time. To open this package, all you need to do is type library survival, since the package is already a part of base R. The functions we chose to focus on are the surv function, the survFit function, the coxph function. We chose the data set named halibut, which names survival times of halibut, including various factors such as length of halibut. The first function, the surv function, takes two arguments, time and event. The time is the time until the subject experienced the event, and the event is the censor that tells whether or not the time was censored. As you can see, a plus was added to one of the data points to indicate that a time was censored. With the is.surv function, you can check whether or not the vector is of class surv. For the second function, the survFit function, it creates survival curves from a formula, previously fitted Cox model, or a previously fitted accelerated failure time model. One possible formula is the surv function that was previously mentioned. After the formula, you need to insert a tilde followed by a 1 or one of the variables in the dataset. If you enter a 1, R will use all of your data to create the curves, and if you enter one of your variables, R will create separate survival curves based on the levels of that variable. The separate variable entered must be categorical. Additionally, to add confidence intervals to the graph, use the conf.type option. The possible options for conf.type are none, plain, and log to log. The default conf.type is log. The confidence intervals are shown with dotted lines. To actually plot the curves, you simply need to put the object you created into the plot function. As demonstrated in the first graph, we use the 1 and the default confidence interval of log. For the second object, we use the categorical variable in the dataset with confidence type log to log. And the final graph is an example of what would occur if a quantum variable was entered. As you can see, the produced graph is fairly messy. For the final function, the coxph function, it fits a Cox proportional hazards regression model, which gives the hazard rate at time t for each subject. The first parameter is the formula, where you insert the response of the left of the tilde and the terms on the right of the tilde. The response needs to be a survival object, so using is.surv response to check if it's true or not is correct. Next, insert the dataset name. Another argument that can be inserted is na.action, which filters out missing data. After this variable is created, you can take the summary function of the produced hazards model in order to get more information about it, including more tests. Although we just chose a few functions, this package has over 50 functions that can do many other things. If you want to know more about this package, read the package documentation that can be found online. This will give you a list along with a description of all the functions in this package. If you already know the name of the function you want, you can simply type a question mark followed by the function name into the R console, and then R will pull up the help file for this function.